Chapter 6, Arrays and Array Lists, Part 4. So to continue with the common algorithms, it's common to have to insert an element in a list. Assume that you want to maintain the proper order. For example, if you are creating an alphabetical list, you want to insert the new item alphabetically. So not just at the end of the list. Keep in mind also that arrays are immutable. That means that their size is fixed. You can't increase the size of the array. So whatever the size of the array is when you set it up, that's how big it's got to be. But there can be elements, as we've seen previously, there can be elements that are not yet used. So you have to maintain a variable. Here in this example, it's called current size, that keeps track of how many elements are currently in the list. Note, it is not adding memory to the array. The array is already a fixed size. So this current size is how many elements we have currently in the array. So if current size is less than values.length, we increment current size, and we have a little for loop where we figure out where this item is going to go in the list. For int I equals current size minus 1, so the last element in the list, I greater than position, I minus minus. So we're going from the end and we're counting backwards. And we're copying the element that's in the previous location to the current location. And then remember, we're working backwards. This is scooting the stuff out of the way in order to be able to insert something in the list. Now, given this algorithm on this slide, we can assume that the variable POS already contains the position where we want to insert the new item. So we work backwards from the end of the list, we add one element to the end of the list, then we scoot the stuff out of the way, and then we insert the element values sub pose equals new element. So here's an example showing the arrows. Working again from the bottom of the list up, we scoot the last element into the new last element that we just created by current size plus plus, and then we scoochy, scoochy, scoochy all those elements out of the way to create a blank space at pose, POS, where we insert the new element. So we move everything down and then insert that new element where it belongs. So another common algorithm is to have to swap elements, and this is very useful in sorting. There are 3 steps that exist in every swap algorithm. You have to create a temporary variable that's of the same data type as the elements in the list. You have to move an element into that temporary variable, then into that location. In this example, value sub I, we move value sub j, and then into value sub j, we move temp. Notice in the code on the gray box that there is a typo. Values should be lowercase v for all of those instances. So to repeat, double temp equals value sub I. Note value sub I is on the right hand side of the assignment operator, and then it goes on the left hand side of the assignment operator. Value sub I equals value sub j. Note value sub j is on the right hand side of the assignment operator, and then in the next statement it goes on the left hand side of the assignment operator. Value sub j equals temp. So we're just swapping those elements. It's also common to have to copy arrays. This is not the same as copying a reference. If you copy a reference, it will just create 2 names or references to the same chunk of memory. Instead, we use the arrays.copyOf method that will copy all the values from one array to another. Growing an array, you can copy the contents of one array into a larger one and then change the reference of the original one to the larger one. Note that if you change the reference first, you'll lose track of the original one and you won't be able to copy it. So make sure that you copy the contents first and then update the reference. As shown in this code, double array values equals new double 6, then we fill the array with some values. Double array new values equal arrays.copyOf values, comma, 2 times values.length. So the second parameter is the length of the new array. So new values is going to have 12 elements, and we're copying all those values from our original array into our new values array. And then finally note that we say values equals new values, so we update that reference. This is the only way to change the size of an array, is by creating a new one and then updating the reference to that array. It's a common error to get length and size confused. So unfortunately, in Java syntax for determining the number of elements in an array list and a string is not consistent. So an array uses a.length, where length is a property or a characteristic of the array. Array list uses size, and it is a method. It goes out and figures out how many elements are in that array list and returns the integer that indicates how many elements are in the array list. And finally, string a.length is also a method that goes out and determines how many characters are in the string and returns that integer.